Hey everyone, welcome back to another video, and in this video we're going to be discussing a very important point, or you can say question of the linked list, that is to reverse it, right? Because this question is very important in terms of logic building, and I've seen that many people do know the code, do know the approach, but they get confused while explaining the code that what exactly is going on. So that's the reason I thought of making a tutorial on it. So it's a very important concept. I will be discussing both iterative as well as the recursive approach. We're going to be taking a look on the logic first, and then we'll try and discuss about the code. Okay, so without wasting a time, let's get into this. So basically this is the linked list that is given to you, and you have to reverse it in such a way that you will be returning the head pointer of the reverse linked list. So in iterative approach, we start from the first pointer, that is from the first node itself, and we work on that. Then we'll proceed one by one to the end. But in the recursive approach, we start from the last position, then we come back to the first pointer, right? That is, we work on the first, that is work on the fifth node first, then on the fourth, then in third, and we move back to the first node. So in the iterative approach, what exactly is the concept? You have to work in such a way that you break the nodes one by one, because you have to work on it and you have to make it reverse. So how you make a reversal? Firstly, you will break this particular pointer. So because just think about it, because 1 is pointing to 2, and eventually at the end you have to point 2 back to the 1. So how you can do that? Firstly, you will have to break it, because if you'll not break it, you won't be able to do any kind of a logic, or you can not be able to do any kind of a thing, right? So that's the reason you break first and second. Once you break it, you start doing the things that you want at the end. You can see that at the end 1 is connected to null, right? So that's the reason you straight away connect 1 to the null. This is the main logic. Now the initial thing has been done. You wanted to connect 1 to the null at the end because that's what the result you need. So you have done that. You have done that particular thing. And also, once you break this particular connection, you gotta need to make sure that you don't lose this part of information. So you gotta need to store this particular information somewhere. And for that thing, you create a temporary node. Once you make a temporary node, you store this address over here. That's when, after storing the address, you connect 1 to the null, right? So this is the first thing that you need to keep in your mind. Now, let's move to the second node. You do the same thing, just you did over here. Over here as well, from 2 to 3, you gotta need to break this particular point, right? Once you break this particular point, you create a temporary node. Once again, you store this piece of information over here. You connect 2, 1 back to the null, or 2, 1 back to the 1. See what's going on over here. Once you're breaking this particular point over here, you're storing the next upcoming linked list to some extra pointer, and also you're connecting the 2 back to the 1. So now you can see that you're approaching towards the right direction. You're moving to your you're moving to your final result. You're connecting 2 to the 1, and you know that 1 is already been connected to the null, right? That's how you approach your question over here in this particular reversal of the linked list. Now, let's proceed further. Let's go to the third and fourth. Initially, 3 and 4 are connected. You do the same thing. You break this particular pointer. You create a temporary node. You store the address of the 4 over here. You connect back 3 to the second node. See what's going on. 3 is connected to 2, 2 is connected to 1, 1 is connected to the null. And you are also not losing the track of this particular linked list. So because this is already stored in some kind of a temporary variable, right? You do the same thing. You break this particular point, and you store this particular information over here. You connect 4 back to the 3. So this is like a chain that is you're making, right? And you have to do that iteratively so that you will be able to get the final answer. And you can see that 5, 4, 3, 2, 1. That's how you do it till the time you hit this particular null over here. That's simple, right? It's just the simple iterative approach that you have to do. You have to traverse through the complete linked list. You break the nodes one by one, and you connect the first node to the back, and also store the upcoming linked list to some extra pointer. That's what you have to do. Okay, I hope this particular logic makes some sense, and we'll also be just writing down the code, and we'll also do the simple dry run for this particular question. Okay, so let's go back to the LeetCode and write down the code. So the code is also very simple. It's just like, as you know, 6-7 lines of code, and then you get your answer. Okay, so the very first thing would be like, you'll check the very simple first condition. If my head itself is equals to null, or my head dot next is equals to null. So in this particular condition, I can simply return my head itself. So basically what happens is, if my node itself, which is given to me, is null, like there is nothing in the node itself, or it's just one single node which is given to me, then I can straight away return my head itself, right? I don't need to do anything. And in order to do my execution, I will be creating two different nodes, and that will be current, that is equals to my head, and also the second will be like previous. So I'll be initializing my previous, that is with null. So what happens over here is that I'm starting with the very first node which is given to me, that is 1. So I'm just making my current pointer to head, and also I'm starting and initializing my previous node that is connected just before 1. Like I'm just initializing with the null, so that I can just, you know, keep on updating my previous with the pointers that I'm gonna be that I will already be worked with, right? So that's what I'm gonna be doing over here. So let's start with the while loop over here, and I will just put the condition as, till the time my current is not equals to null, I'll keep on iterating inside of this while loop. Okay, so now what happens inside of my while loop? Inside of my while loop, I will be writing down my conditions. Like I mentioned, that I will be initially like breaking this first and second, and then I will do the manipulation. Okay, so how do we break the connection in between two different nodes? I will just simply make a temporary node. This is my temporary node, and inside of this temporary node, I will be storing the address of my current dot next. What is my current dot next? It is basically the linked list, the upcoming linked list that I have. So like I mentioned, we'll be creating a temporary node again and again, and we will be storing the address of the upcoming linked list inside of this temporary node, so that we can break the connection and we can connect the current node towards the previous node, right? That's what we are doing over here. Okay, now this has already been stored inside of the temporary variable. Let's proceed further, and after that we gotta need to update my current dot next to what? To the previous node, right? So what basically this is gonna do that first dot next will be equals to the previous. What is previous? Previous is basically null. So that means the next pointer of 1 will be pointing to previous, which is null. That's what it's gonna do. Okay, now that my part which I wanted to do is done, because the upcoming linked list address is already stored and my first is also connected to the null, I just need to update my previous and current now. And how do I do that? So firstly, I will be updating my previous, and my previous will become my current, because the work which I wanted to do on current is already done. And also my current has to be updated, right? So current will be like my temporary node. Temporary node is something which is the address of the upcoming linked list 2, 3, 4, 5, right? That's what it's gonna do. And at the end, I have to return the previous, not the current. The reason is very simple, because at the end, what's going to happen when we will be working on this fifth node, it will be having the next node, that is a temporary node, which will be null. So I don't want to return the null. I have to return the previous. The previous is going to be like my 5 node, right? So that's the reason I have to return this piece of information. Let me execute this. Okay, so we are getting some kind of an error. Cannot find the symbol list. Okay, so it's just the syntax error that we are getting. Let me just submit this straight away. Okay, as you can see that this has been passed. And yeah, the code is pretty much simple. You just have to think about the process that I explained you initially. You just have to break the connection from 1 to 2. You have to store the upcoming linked list in some kind of a variable. We did that using a temporary variable wherein we stored the current dot next. And then in the current dot next, we connect like this current dot next, that is one dot next will be connecting to the previous, right? That's what we do. And then we straight away just update our variables, and then at the end we return the previous. I hope this makes sense. I hope the code is clear and also the logic. So let's move towards the recursion part. So in recursion, what really happens, it's also very simple. Like I mentioned initially, that recursion works in such a way that you're gonna be taking the fifth node, that is the very last node first, and you will keep on returning the last node itself. Because over here as well, we do the same thing, because we have to, initially what is given, this 4 is having a connection to 5, right? So we have to go back. So that means 5 has to be connected to 4. So this is what the logic we have to perform. So in order to do this kind of a logic, in order to, do some kind of a manipulation over here, we gotta need to break this node. So once we break this, we need to ensure that 5 is now connected to 4. So how do we do that? Over here as well, what we do, we create a temporary node. Okay. So in recursion, right? I mean, when you are working on some kind of a recursion logic, you need to firstly understand what is the return value, what is something that you have to return. So in every single, recursion, you will be returning this pointer only, right? You're going to be just returning this 5 only again and again. And you're going to be making sure that whenever you are doing some kind of a work in every recursion, you are taking the address of this and you're connecting 5 to 4, 4 to 3, 3 to 2, 2 to 1. So this is what you need to make ensure. How do you do that? So firstly, when you are on the very last recursion, on the very last step, that is basically the very first step, right? So in this particular step, you create a temporary node over here, and inside this temporary node, you store the address of this. You store the address of 5 inside of this particular node. Let me just clear this a little bit and explain you this thing once again. Okay, so like I mentioned, that we gotta need to break this particular bond, this particular connection over here. We create a temporary node, that is node n, you can say. And inside of this temporary node, you store the address of this. Okay, so now this n is basically containing the address of this fifth node. So what you can do, you can make a connection between n to 4, because eventually what is happening, we have just stored the address of 5 to n, so n is now going to be pointing to 4, and we will make a connection that n is gonna this 4 is going to connect to null, right? This is what we do in the very first step. Then in the next recursion, because it's a backtracking kind of a thing, so we'll move back, and what do? We create a temporary node once again. We store the address of 4 over here. With this particular n will be now connecting back to 3. And we'll return the 5 only. Because initially what we did, we already made ensure that 5 is connected to 4, and now 4 is going to connect to 3. See what is happening. In the iterative approach, we were moving further. Like we were moving from the first to the 5, and we were creating a temporary node again and again, and we were storing the address of the previous locations, right? And we were connecting that to the back. But over here as well, we are starting from the last location. We're creating the temporary node once again, and we are storing the address of 4 to the n, and this n is going to be pointing to 3. So over here as well, you will do the same thing. This 3 is going to be having the address inside of this particular n node, and this n is now connected to 2. This is what we do, right? So let me write down the code because it's a little bit clear. I think that it's a little bit clear, but once you will look at the code, it's going to be more clear, because then you will be able to understand the recursion process as well. Okay. So let's go back to the LeetCode screen and write down the code over here. Okay. So the very first condition will be the same thing. That is, if my head is equals null, or I can say my head dot next is equals null, I'm gonna need to just simply return my head pointer. Okay. So this is the very first simple thing that we have to do. And now I will be creating a new head, and that's going to be like taking reverse list. What do I need to pass on over here? I just need to pass on my head dot next. So basically what is happening, see what is going to happen over here. Till the time I'm not going to hit my last node, I'll keep on calling this method, because what's going to happen, one is going to come, that is going to pass on the second pointer, then it's going to go for the recursion, then again it's going to come to the 2 is going to point to 3 is going to be passed on towards this method, then 3 is going to pass, 4 is going to pass, 5 is going to be passed, right? And what happens when it reaches to the 5, because 5 is what, 5 dot next is null, so that's going to return my 5 over here, right? So this new head is going to be like what? Let me just also be writing the values over here so that it will be easy for you to understand what's going on. New head will be equals to what? 5, right? Let's proceed further. Like I mentioned, we'll be creating a new node, so I'll call this as temp, and this temp is gonna store what? Temp is gonna store head dot next, right? So that means temp is also gonna be pointing to 5. I hope this makes sense. Now what do we need to do? We need to make ensure that this temp dot next will be connected to 4, right? Temp dot next will be pointing to what? Because over here this is this, and head is basically what? 4. Because I'm talking about the 4th, I'm talking about this particular part of execution. 5th is straight away returning me the head, right? But I'm talking about this 4. This is this 4th execution that I'm talking about. So what happens over here? This temp dot next will be equals to head, and now what? Okay, so let me make the connection over here, because initially we made the temp as 5, and 5 is now connected to what? This temp dot next will be pointing to what? This 4th node, right? This 4th node is basically what my head is, and I need to do one thing, that my head dot next will be pointing to null, right? This is what I need to make ensure, because I don't want to go back. I don't want to make a circle. I don't want to make a loop over here. I don't want this head dot next again going back to the 5. This is not what I want. I just want to make sure that head dot next is equals to null, right? This part is done. What is left? I can simply return this thing now, right? This part is already being done, and what do I need to return is basically new head. So in every single iteration, my new head is going to be returned. Let's just try and run this piece of code. Right, so this is working, and let me explain you the things once again so that you can have a gist of it. We'll do the dry run over here for this particular code. So let me just open this paint screen Okay. So now just look at the code, what is going on. The very first thing that we did over here, that we just check that whether my head or head.next is equals to null or not. So in this particular iteration, how exactly the code is working, we are reaching to this particular point when 5 is going to be returned at this particular location. From this particular reverse list, head.next, this new head will be my this particular 5 number, right? So for that thing, I just created a new variable over here, and this new variable is basically I've just created a new variable so that it can store the value of this particular 5 over here. Once it is having the address of this particular 5 node, it is now gonna be pointing to this 4. This temp.next will be pointing to the head. That's what I do over here, so that I can use the address of 5 and I can return this to every single recursion, and end.next will be equals to what? This particular 4 number. That's what I do over here. And till the time I'm just doing the same recursion and recursion thing, when it's going to come to this particular piece of recursion, from here as well, I'll be creating a new variable, a new node, and this address will be stored. And this end.next will be, this temporary .next will be pointing to the 3, right? And then at the end, again, I'm just returning this 5 node. I'm just making ensure at the backend, all the addresses are pointing to the right location. And that's how we return this particular linked list at the end, right? I hope this makes sense. I know this is a little bit tricky, but this is what the approach is. You just need to make ensure that you create a new pointer, you store the previous value, and you just point it to the right direction. And I tried my level best to explain you the things, but you still have any kind of a question or any kind of a doubt, you can put that in the comment box. I'll try to give you the answer back. Just try to learn things, just try to make a dry run of it. And this is a very simple code. And yeah, that's it from my side. That's it in this video. Thanks for watching. See you next time.